Welcome to the I Nurture videos.
Hello students, how are you doing today? In this video, we will discuss about what are Unix process, states and how state transition occurs. Before that, let's just revise about process in Unix. What is a process in Unix? Whenever you issue a command in Unix, it creates or starts a new process. In simple words, a process is an instance of a running program. There are various states of a process in Unix. There are 5 states of a process in Unix, which are running, runnable in memory, runnable swapped, sleeping in memory, and sleeping swapped. An active process is normally in one of the 5 states. There are various transitions that take place from one process state to another. Let us now see how this process state transition takes place. A process is running if the process is assigned to a CPU. A process is removed from the running state by the scheduler if a process with a higher priority becomes runnable. A process is also preempted if a process of equal priority is runnable when the original process consumes its entire time slice. A process is runnable in memory if the process is in primary memory and ready to run, but is not assigned to a CPU. A process is sleeping in memory if the process is in primary memory, but is waiting for a specific event before continuing execution. For example, a process sleeps while waiting for an I/O operation to complete, for a locked resource to be unlocked, or for a timer to expire. When the event occurs, a wake-up call is sent to the process. If the reason for its sleep is gone, the process becomes runnable. When a process address space has been written to secondary memory and that process is not waiting for a specific event, the process is runnable and swapped. If a process is waiting for a specific event and has had its whole address space written to secondary memory, the process is sleeping and swapped. If a machine does not have enough primary memory to hold all its active processes, that machine must page or swap some address space to secondary memory. When the system is short of primary memory, the system writes individual pages of some processes to secondary memory but leaves those processes runnable. When a running process accesses those pages, the process sleeps while the pages are read back into primary memory. When the system encounters a more serious shortage of primary memory, the system writes all the pages of some processes to secondary memory. The system marks the pages that have been written to secondary memory as swapped. Such processes can only be scheduled when the system scheduler daemon selects the processes to be read back into memory. Both paging and swapping cause delay when a process is ready to run again. For processes that have strict timing requirements, this delay can be unacceptable. To avoid swapping delays, real-time processes are never swapped, though parts of such processes can be paged. A program can prevent paging and swapping by locking its text and data into primary memory. Dear students, in this video, we learned about Unix process states. There are 5 states of a process in Unix, which are running, runnable in memory, runnable swapped, sleeping in memory, and sleeping swapped. An active process is normally in one of the 5 states. Subsequently, we covered how state transition occurs. Trust you will find the information useful.